Coming up next on the IP Talk stage, Tim Vanevenhoven from Xilinx, presenting Enabling IP-Centric Design, introducing Vivado Design Suite.
Thanks for inviting us into the booth here. So my agenda today is why now? Like, we're introducing our new Vivado Design Suite. So the question is, well, why are we doing this right now, right? Why not 5 years ago? Why not next year? What are we doing? We really want to focus on accelerating customer productivity. So how are we doing that? Talk a little bit about packaging IP for reuse. As our devices are getting larger and larger, you're going to need to use IP in order to get started. So how are we going to do that? Introduce the Vivado IP integrator, a way to stitch together all this IP. So you're going to go to this portal, you're going to get all this IP. How are you going to stitch all this IP together? Talk about our ecosystem, quick summary, and a Q&A. So feel free to interrupt me as we go along the way here. All right, so the first thing, why now? So if you look on the left-hand side, Xilinx has really was always thought of as a logic company, right? Like, you did glue logic, you were an FPGA, you did chip selecting, things like that. Over the last 20 years, we've really evolved, and now it's not just FPGAs anymore. We've got our AMS, which is our analog mixed signal block, which is built into our FPGAs. We've got a hardened ARM processor, dual-core hardened ARM processor in our Zinc devices. We're using our 3D IC technology to put together, we have FPGAs now that have 5 different pieces of silicon all stitched together inside of one device. So the more than Moore's law approach. So now people are putting software, they're putting algorithms, they're using our gigabit transceivers, they're using AMS, they're adding logic protocols, they've got soft processors, hard processors in there. So it's really become an all programmable device now. It's not just simply an FPGA. And as these devices are getting larger, the technology we were using 15 years ago just isn't scaling, right? So that's why we knew about 3 years ago, we knew this was going to happen, and we started this project, and now we're just releasing it this summer. So, and that's where Vivado came from. So the real focus of this was, let's accelerate user productivity. So on the left there, we've got kind of the standard RTL to bitstream iterative approach, kind of a scale factor of 1. And our goal was in 2 areas, to accelerate integration by up to 4x, and then over here to accelerate implementation up to 4x. So on the integration side, we needed to figure out a way for people to bring together their IP, get their IP into the device, and be able to reuse IP. And then on the accelerating implementation side, as these devices are getting larger, people can't wait 24 hours for a place and route, right? Or they can't have a machine that needs 128 gigabytes of memory. We needed to figure out some way, as the devices are getting larger and larger, how do we make our software such that the place and route times where you could do a couple design turns per day, and you could do it on a realistic laptop that you could buy online without needing a server farm just to do a place and route. So those are the 2 areas that we really focused on, and one of the key enablers to this was adopting industry standards. For those of you who have used Xilinx tools before, everything is proprietary. Every file we write out is proprietary. We've got our own constraints, formats, all these things, and now moving forward, we've adopted AMBA and ARM, so using AXI4 for our interconnect. IP-Exact is the way to represent the metadata for our IP. Going to TICL and SDC, so we have industry standard design constraints. IEEE 1735, this is a big one to protect our IP, both our IP that we produce and then also our partners' IP, so that it can be simulated with tools from the big guys, Mentor, Cadence, Synopsys. We can all interchange IP and at the same time protect the intellectual property that the IP developer put together. And then System C and System Verilog. So it's really around accelerating productivity, and how are we going to do that adopting industry standards. So the IP-centric flow then is, I don't want everyone here to have to learn how to write IP-Exact. Like, you don't want to have to study how to write IP-Exact. So what we have inside of Vivado, we're calling it the IP packager. And the idea here is that you take your source code, your simulation models, documentation, example designs, and test bench, you run that through the IP packager, which is basically a wizard, and it actually writes out all the IP-Exact metadata for you so that your IP can go into the Xilinx catalog. So our own Xilinx IP developers use this internally. That's how we get IP into the catalog. We've provided it to our third-party partners so that they can make their IP available in the catalog. And then our user community can also use this so that you can develop IP and add your own IP into the catalog, share it with your colleagues, or start a small company and sell your IP. We've enabled that methodology. So now all the IP is in one catalog. In the past, we had multiple different catalogs. Now we have one catalog. And the other exciting thing is, in the past, our IP catalog, we shipped it with the tool, and then that was it. Once you installed the software, that was the IP catalog. Now it's dynamic in that I can go to the Chip Estimate portal, find a piece of partner IP, buy it, the partner provides it to me, I put it on my laptop, I click refresh, and boom, that piece of IP is now in the catalog. So I don't have to wait 3 months for the next version of Xilinx or anything. You can actually install the IP instantly. And then I'm going to touch briefly on, now that we've got all this IP in the catalog, how are we going to stitch it all together in an easy-to-use design environment? And that's where the Vivado IP integrator comes in. So this enables you to share IP within your team. Third-party IP delivered is delivered with the same common look and feel. So the IP you get from Xilinx.com is going to have the same look and feel of the IP that you find on ChipEstimate and then purchase from one of our partners. And then you can reuse your IP at any point in the process. So, maybe I want to share some source code with you. Maybe I want to share a place and routed piece of IP. Well, we've enabled that also. So what is the Vivado IP integrator? So this is a graphical environment that's going to enable rapid connectivity of complex IP. So now that we have this IP in the catalog, I can actually drag and drop this IP onto this workspace or this canvas, and I can make connections. So, and at a quick look, you might say, oh, it's another schematic capture tool, right? But if you look real carefully, these lines are not representing individual nets or buses. These are representing interfaces. So we're connecting interfaces together. So this could be an AXI4 master connected to an AXI4 stream. So one of these heavier blue lines, one of the heavier blue lines could be an actual master to a slave connection. There might be a half a dozen or a dozen signals underneath there. And because we have all the IP exact metadata inside of Vivado, we can connect that IP for you. So you just have to show us the connectivity of your IP. So you show us which masters are connected to which slaves, and then how your IP is connected together, and then let us generate the RTL for you. And this is designed to work if you have a processor, or if you don't have a processor, it's agnostic to that. It works for DSP designs, video designs, all different types of designs. So this is a really exciting new capability that we're going to be introducing into Vivado later this year. And it's tightly integrated into the packager so that I can build this. Maybe this is a new piece of IP, Tim's awesome IP. And now I want to run the packager, and I want to add this back into the catalog and then share it with you. So you can actually take IP to build more IP, and you can have this iterative process. And our philosophy is, as these devices are getting larger, that's what people are going to want to do, is take smaller IP, build larger IP, and that's how we're going to fill up these larger devices. So we have a broad Vivado ecosystem of support today. So on the top here, we have our ecosystem IP and service provider partners. And then on the bottom here, we have our integration and interoperability, other EDA partners. So we've included our ecosystem from the get-go. So we actually invited these IP providers into our headquarters like over 6 months ago, and they were actually using Vivado, and they were starting to package up their own IP, so that over the last 6 months, they've been part of our beta program. So they're now ready. They have IP available. Their IP has been working in the Vivado toolchain. So you can actually go to some of these partners and request a piece of IP that's already been integrated into Vivado. So they're using the IP packager just like our Xilinx employees are using the IP packager. So when you install one of their pieces of IP, it's going to look and feel just like the rest of Vivado, and it's just going to fit right in. And that was really our philosophy. So you can visit Xilinx.com for more information on our Alliance program. And now we get to design planning. So now I want to do my design. How do I collect all this IP? How do I know what IP is out there? And that's where ChipEstimate really comes in and helps us, is that you can go there, you can go to the Xilinx microsite, and you can search for a particular piece of IP that maybe Xilinx doesn't offer. But in this one-stop shop, you can find out that one of our ecosystem partners provides it. And now with this new flow that we have, you can purchase a piece of IP from our partner and then use it in the Vivado suite just like any of the other pieces of IP. So that's really the additional value here. So our goal here is to enable a new level of IP-centric design, and that's the reason why we designed Vivado from the ground up, thinking that devices are getting larger, people are going to need ways to use IP and reuse IP.